see anything when I came back. Alright. Bell ringer is stopping. Let's look at it. What do you mean timeout? We've had 5 minutes. It's one question. 10 of us have an answer in. You got 30 seconds.
Oh my God, wait, I have
Okay, let's look at it. I need y'all to hear me very clearly on this. Okay, first off, we have got to make sure that we are working efficiently on these. I know that y'all are still practicing this, but I will tell you, realistically, a problem like this, 60 seconds, once we're getting comfortable with it. But we got to get seated, we got to get to work right away. Like most of us didn't even get out our notes remotely for this problem until 3-4 minutes in. We got to get going, we got to learn as much as possible. Now, let's look at these. I do want to look at these two right here. I saw a couple people write y equals -2/3 plus 6. This is a great mistake that we need to pay attention to. What's the error here? There's no x. Does anyone know of an efficient way that we can help focus our attention to make sure we don't miss that x?
Write the formula.
Can't you write out the formula ahead of time? That's where you want to start. You need to know, hey, this is a linear equation, and so or a linear function, so we're going to write out the linear equation y equals mx plus b, and so it's a great place to start. So how am I going to identify what m is? Say that one more time for me. Rise divided by run. Okay, that's the way we're most often used to it, but what's another way, especially if we have a table? Change in y divided by change in x, right? So delta y divided by delta x, or change in y divided by change in x. Either of these work. Regardless, when I look at this graph, what do I see? I see a linear function. I don't see the equation yet. But what's the slope, the rate of change? -2 divided by 3. And I did have one person in earlier class ask, hey, Mr. Kinney, how do you know that? Well, you need to identify what on that graph? Partially. Say again. Don't we need 2 points? And there's quite a few points. Notice you really want points that are on a perfect intersection. It doesn't matter which two you choose. Right? If I go here to here, notice how I'm using arrows to indicate directions, right? It's not just, it is down to, but I hear a lot of students say over. That's not just over, that's to the right, so I'm going to add 3. Okay? Or I could go this direction. Up 4 to the left 6. Regardless, do I get -2/3 as the slope? I do. Okay, Amari, you did something else to get you started though here. What did you do? What did you make? Did you not create something on your paper? Could you make a table to help with this? Right? I mean, it's just taking those points here, right? Don't make it more complicated than that. Like if I look at this point, that is -2, 7. Right? Here's a point, 1, 5. Here's a point, 4, 3. And 7, 2. And do we see the same pattern of -2/3? Right? Change in y divided by change in x. Now, this table will, right, so again, change in y over here on the right-hand side, change in x on the left-hand side. This table will help point something out. Can I actually use slope-intercept form?
We don't get a perfect y-intercept. We use point slope form.
We have a point, we have a slope, but do we have a perfect y-intercept? No. Meaning we don't have an integer value for that y-intercept. We should have paid attention to that. A lot of us said 6, but does that intersect at 0,6? No, it does not. I saw some people say 5.75 and 5.8, and is that close? Yes. Is it accurate?
No.
No, it's close. But Deja, say it again. What did you say we have here? We have point, not even just one. We have lots of points, and we have a slope, right? So we need to use which equation? Point slope. See, these are things that we want to think through. Yes, and so here's the thing. Could you write out y equals mx plus b to start? Heck yeah. You calculate your slope. Okay, we've got that negative 2/3. But then when we start looking at that y-intercept, we should say, yikes, I don't have a y-intercept. I need to change my game plan. I need to switch to plus y1. Guys, this is an equation that you really need to learn because it ties directly into one of the quadratic equations. Which ones? Or which one? Not the standard. The vertex form, right? Remember that vertex form of a quadratic, instead of m, it is a. Instead of x1, it is h. And that's squared. Instead of y1, it is k, right? We need to see those connections. That should help us learn these different forms efficiently. And so, all right, now I have my slope. Does it matter which point we use? No. I might use the 1,5 just because I like to deal with smaller numbers. Maybe the 4,3. It doesn't matter. No matter which point I use, if I graph those equations, I get the same line. Now, I can simplify from here, and I just want to show you one thing, right? Y equals negative 2/3 x. Negative 2/3 times negative 1 is plus 2/3 plus 5. Now, your calculator can do 2/3 plus 5 as is, right? So, if I go to, can you open the door for me, please? If I go to 2 divided by 3, right? 2/3. Yes, ma'am.
You have one more.
Okay, and I have one more to give back to you. I didn't notice you gave me one for Anna Grace.
She's not in here.
She's in Miss Dennis's room. Where did I put that one? Here it is.
Thank you.
Yep, thank you. Okay, so 2/3 plus 5. Notice it gives me a fraction, right? It goes ahead and gives it to me as 17/3. Which, what is 17/3 roughly? Anybody know? What's 18/3?
6/3.
So 17/3 would be a little less than 6. Specifically, it's 1/3 less than 6, or 5 2/3, which we did 2/3 plus 5, 5 2/3. So was 5.75 close? Yes. Was it correct? Not quite. We would need to recognize that we can't use slope-intercept. We got to use point slope. And also, again, don't forget you can convert that to a decimal pretty easily. 5.6 repeating, but I would leave it as a fraction. What are your questions, comments, or concerns before we get it back into quadratics today? What'd you say, Deja? Okay. Anybody else? Hi, Jordan.
Hey,
Good afternoon, Jordan.
I already said it.
Did you?
Yeah, I said it, but you didn't hear me. I said it
I
without
heard
you
it.
telling me. So I knew, so you knew that I was ready for it.
Okay. So what are you?
I don't know.
James, I forgot to tell you good afternoon when you came in too.
I'm faithful.
Thank you, sir. I'm glad you're aware.
Say it like that, Jordan.
Come on, Jordan. What are you?
I already said it.
I didn't hear
It can only come out one time a day.
That's not true. You're always capable.
I just
Say
it was
it.
like the easiest thing to say. At least they making us so
You-
powerful and all the things around.
And what? There you go. All right. So, hopefully that is a good little recap. Please note, make sure you take the time to write out that equation. It helps you focus your attention. It's also part of the justification process to show how well you really understand it. Ms. Essel and I started looking through at the understanding checks and started talking through those ideas that I am looking for you to show that for evidence of your understanding. Okay? Write out the equations. Hey, Bree. Hood off, please, and glasses off. Thank you. All right. But again, if you don't have a clear y-intercept, you need to do that point slope. Okay, so here's our agenda for today. So we're going to get back to the textbook, that lesson 4, true to form, and just focus on forms of quadratic equations. Just as a heads up, especially based on where we got in first block, we will have an understanding check on everything from the Desmos activity and from this lesson in the book Wednesday to start class. Okay, so Wednesday to start class, we'll have an understanding check on these forms of quadratic equations and things like that. And so we will wrap this lesson up tomorrow, have practice on for the rest of Tuesday, and understanding check on Wednesday. And so a big part of this stuff with quadratics is what math is at its core, and what is that? We got to pay attention to that study of patterns and relationships. I saw eyes this morning in first block, and I need to emphasize this to him tomorrow, but I saw eyes this morning like, Mr. Kidney, this is so much I have to memorize. And it's not if we understand what the language means. Because if you understand the language for these patterns and relationships, it's just a few patterns that you have to remember, which is way easier than memorizing a whole lot of isolated facts. But here's where we are, lesson 4, true to form. And we're trying to analyze the forms of quadratic equations. What are those 3 quadratic equations again? Vertex form, standard form, and factored form. Those are the names. You need to know the equations and what the different pieces of the equations mean so that you can write the equation, and also so that when you look at an equation, you know what the features are of it. Okay. I'll get to them. I don't know any right there.
Is Grace in?
Yes. Or no, wait. Is she in here?
Yeah.
No. I have EK Alex, Alexa, or Lexi, and Jordan. We'll figure it out. Okay. And then we want to identify the features of a parabola based on the form. And so we're going to look at that. So we already talked through. Yes, ma'am. Hold on one second. This is activity 4.1. This is, I meant to have this on presenter view. Activity 4.1 starts on page something, 54, M154. But remember, we don't have anything written here, because where can we find the information about each form?
Our notes.
Which set of notes? Right, so remember that Desmos activity with the forms of quadratic equations, that's where we can find all the information about the quadratics. In first block, some people were like, oh, the Venn diagram. No, what is the Venn diagram all about? What is it? No, the Venn diagram. There we go. Quadratic, linear, and exponential is the Venn diagram. The Desmos activity was the 3 different quadratic equations. And we talked through this. As a quick reminder, right, this supplement, right, which is based on something in the book, is helpful because now, based on, if we have the factored form, what were we able to find from the factored form now that we couldn't originally? That is the x-coordinate of what? It's in this written portion. Not, well, the factored form gave us the x-intercepts, but this was a supplement to say that if we have those x-intercepts, we're going to average them to get the x-coordinate of the vertex, right? So remember, if you have the factored form, you can find the vertex because the x value is the average of those x-intercepts. If you have standard form, how are you going to find the x value of the vertex? Eventually. So remember, we need that negative b divided by 2a to have the x value, and then we substitute in, right? So you need to be able to find the x value of the vertex to get you started. So this is what got us up to part 3, or question 3 on M1-56, and we finished cutting out these equations and these graphs that are actually on pages 69 and 71. Okay? So we need to have those equations and graphs out. They should already be cut out from pages 69 and 71. But what are we going to do with those equations and graphs? Okay, we're going to, and we're not taping, there's glue inside of the boxes that are on the desk. You're you're going to glue the quadratic equation to its corresponding graph. Now I need y'all to hear me very clearly on this. Alright? To be efficient, one, are we going to glue as soon as we think we have found a pair? No, because if you done messed up, it's going to be really hard to get that equation off of there. Secondly, alright, should you look at the graph first, or should you look at the equation first?
Equation.
Yes.
Why would we look at the equation, Deja? What's your thinking on that? Okay, so can you see the concavity from the equation?
Yes.
And that would help you eliminate some of the graphs, right? What about if you have factored form? What are you going to immediately look for on the graph? Guys, if you have factored form, what features of that parabola should you be looking for? The x-intercepts. So isn't it really easy to look at the equation and say, hey, these are the features I want to look for? Okay, so I would look at the equation and find the graph that matches it. Finally, actually no, there's two more things. So, the other thing is this. Once you have paired your equations with your graphs, you're going to go to, I think this is page 73. Okay, page 73, and what you're going to do is glue the graphs and their functions here that go as standard form. On the next page, I think you have factored form, and then the last one is vertex form. So you have 3 of each. Now I need y'all to hear me very clearly on this. Pause and listen. Is this an individual learning activity, or is this a collaborative one?
Collaborative.
So, what should you probably do to efficiently help everyone make sure they get their graphs and equations together? So how are we going to, we got to talk, but how are we going to work together? Would it be beneficial to let Cole work on equation B and Cannon on equation C?
No.
Are they going to be able to collaborate like that?
No.
So you know that you want to look at the equations. Talk with each other, identify the equation that you are working with together, talk through the features that you see in that equation based on the form of it, and then find the graph that goes with it. Ms. Essel and I will be coming around to help support you and ask questions and check on your answers as you're moving. But what are your questions at this point before I release you to work? 3, 2, 1, go. Leah, what was the question? I mean, you don't have to be, but I don't think you're going to be able to collaborate very well that way.
Okay, you understand? No. I'll say, any questions for me? I'll say yes. The easy thing to look at is concavity. We're just matching up the equations that have concave down. So what value? Concavity. Did you match somewhere? Yeah. I think that's the easiest one.
Be careful. Be careful with your language of it's a negative. But you just said it's the opposite. The x-intercept should be the opposite, right? Does that make sense? So be careful that factors that the R and R2 are the opposite of the sign that's inside the
So
parentheses.
basically you're saying y-intercept.
You see what I'm saying, right? X minus 1, so the intercepts will be 1, 0.
This equation, because the y-intercept is when x is
I got
equal to 0.
No. So you can't say
That equation, these two terms go away because there's an x right there, and you would just be left with 16. So the point would be 0 to 6. So yeah, that is right.
Well, notice this space down here is for you to graph or to glue the equation, and then you glue this onto there. So I would find all of my equations and graphs first, and then sort them. Okay. That's what I do.
Not factor form. Do y'all know what form is I?
This is two letter.
Alright, let me know when you complete done, I'll check over quickly. And then I'll need some vertex before we have a full class session. Someone call my name. What?
What the vertex is. So what two numbers jump out to that?
Which one?
in that equation.
Did you figure it out? A, B, C, D,
What's your number stuff out of
E.
you? Okay, that's one of them. Yeah, I agree with that. What's the other one that comes out of you? Yeah, perfect. Okay. So vertex is
Missing
opposite of
equation
this
G.
value. So it's negative.
So let's do this.
Negative.
Why don't we all look at our equation G right now, figure out which one it goes with, and then you just write your equation to the correct graph. Does that sound like a plan? Yeah, equation G. So, when you say, so which form are you looking at there with equations? Factor form? So you're looking at which features? So what is the x-intercept? So one thing I'll caution you on,
So G, what form is that?
an x-intercept, just like a y-intercept, so you wouldn't just say 3. What would you need to say? 3, 0. X-intercept. So let's find that graph together. It seems like we're kind of working as two different groups.
Vertex has like 2 points in it. There's always going to be like parentheses and then there might be end. Yeah, -4,
Hey,
not
one
2.
thing I forgot to tell you, one thing to focus on is we're not using
That's your vertex. I'll see only the one inside.
Oh, you're just checking.
And then also you can look at also you can look at this sign right here. That's negative, which tells you it's going to be right now. Does that make sense?
Hey, really quickly, Clay's in the library because he has a bum foot or something. Logan. Alright, how's it going over here? Well, and that too. Well, what questions do we have right now?
So they're all quadratic.
Okay. Now we're gonna go through.
Vertex. Okay, vertex one.
Why'd you grab that top?
Which graph to match with? Yeah. So vertex, what two numbers stand out to you in that equation?
Guys, I would look at equation F quickly. Because here's the thing, what
Specifically though, the vertex, you're
and
already saying it's
immediately when I look at that,
opposite
I should know the concavity.
Okay,
What
so
that
one
matters,
would
right?
actually be
Concave.
-4.
What's the
And
y-intercept for
the
graph
number
or for
outside
equation
parentheses
F?
is just the same. So it's -1, -2. So I'll look at all your graphs. We know it's common.
So maybe, but you're talking about equation F, right?
Down.
Where's equation F for you? Right there? What is the y-intercept for equation F?
Based on that information.
-1. When you look at B, it's the y-intercept? Right. This is why I went in blue first. I don't think this one's going to go here.
Wait a minute, where do I have it?
Explain it again.
Okay, so like, you see how it's if I put a dot there.
I would not glue until I have all
Exactly.
of them.
Yeah, so that, either the maximum value or the minimum value, that's your vertex. So, where it kind of starts curving, the top
I would
of
just
that
pair
curve.
them all together and then it should be easy to identify
So right here, the
which one
vertex
goes
is
on
on
which
-2,
thing, because
-2, and it's
standard
on
form's easy to identify, right? So that's a good question. If you look at graph D, could that be a y-intercept of -1?
That makes more sense, at least for vertex form. What about, do you want me to take that?
I will point out, when there's standard form, we now know how to find the x-coordinate of the vertex. Isn't it -b divided by
So
2a?
factor form very easily gives you your zeros.
The x-coordinate of the vertex is that -b divided by
So if you're
2a.
setting
That's something we talked about.
Each little
So
parentheses
the opposite of
equation
12
is zero.
is
It's
-12
just the opposite of the
divided by
number.
2 times
So
a.
looking at,
A is just a 1.
So like.
So be -12 divided by 2 is -6.
We were set x minus 1 equals 0.
Look at that graph. Could the x-coordinate of the vertex be -6?
So a 0 to the right, whatever. So
Right, -5, -6, a little bit. That would make sense. By the way, one thing I would point out is make sure you glue it down. So maybe F will go with D.
Can I
But I would again, so like I will confirm that those three are correct, I believe. So you can go ahead and glue those down, but I would wait to glue anything else till you have all four. Okay. Did y'all come up with a solution then? So y'all have
What's your first one?
quick question. It looks like you all have some decent understanding here, so we're all going to participate in the whole class discussion today, right? Of that active collaboration score? But you're talking it through now, like you know stuff, get involved in the conversation. Even if you get things wrong, that way I can hear mistakes and help you correct them.
Zero, so we'll make that. We're substituting zero in this y value because the y value is zero on the intercept. So we're going to say zero is equal to x minus 1.
Wait, you think F and B go with those two graphs? Because when I look at graphs, G goes with what concavity is that? Down. Does G go with H?
Yes.
When I look at equation G, what features should we see from equation G? But listen to my question again. What features can we see from that equation G?
This is the one we did Friday.
It's concave down, cool. It's vertex one, so what's the vertex on G?
It's opposite sides.
What's the vertex? Answer my question. What's the vertex for G? I'm looking at the equation. When I look at that equation, where is that? Here's my vertex one right here, right? When it's A times x minus h squared plus k, H, comma k is my vertex.
I'm done.
Are you looking at the equation or the graph? Not the actual positive two. Because remember, right here, to get x plus 4, h has to be 1. Okay, so h is the x value of your vertex. Remember, one thing to keep in mind here is that the x value of the vertex goes with vertex. So if it's negative 4, comma, is that negative 4, negative 2? That's negative 1. That's negative 2, negative 4, not negative 4, negative 2.
So all I'm
Not negative 3, negative 2, and negative 2, negative 4, the same thing. See, if you what might help, okay, is if you show work. So I need to find a vertex that's negative 4, negative 2. Why don't you look at H? If negative 4 is your brain will react. Look at graph H. Look at graph H. What's the vertex from graph H? Oh.
Don't know what she's talking about.
I'm gonna go check out another group. Looks like one of those sure about that?
Do you know what your glue
Okay, calm down.
But I'm getting ready.
Appreciate you moving forward.
everything? Okay.
I gotta ask, are you sure that H is 4?
Yes, why?
Because
So you gotta remember with that H, it's the opposite.
Yeah.
Right? 'Cause
Okay, so
it's originally
what's your x-intercept?
H, so you get x plus 4. it had to be x minus negative.
Yeah. So 3 and 3 is 3 equal to 3. Yeah, so there's just one x-intercept at 3.
Say that again.
Okay.
Are these two right?
So this equation G.
Okay, so what is this one telling you?
I would point out you're saying that the vertex
This
is
is,
-4,
factor
negative
1.
2.
Right?
I don't
So
know
it
that
tells you
it's
your zeros
your
for
vertex for
x-intercepts.
Don't you, Tom?
You're close.
Yeah, just don't even worry about
That
it.
vertex
The
is
a tells you
-4.
But for this, it's saying x minus 1 and
You look at
half.
graph,
Those give us like our x-intercepts and what's our y equal to.
that's halfway. X is -2.
Because we're crossing the
They're not
x-axis.
listening to me when I'm right.
Do what?
They don't want to listen to me when I'm right.
I got it. Yes. So this one right here, the vertex is
It's this one. It's so it does match.
Why?
the vertex, you just drop that. Sure, that all makes
So equation E, x minus 1, x minus 5, those are your y, or your x-intercepts, sorry. So you should have an x-intercept at 1 and an x-intercept at 5. It's just the opposite, right? So do you see an x-intercept at 1 and 5?
So is that the same?
What does x-intercept mean? What does it mean to be an x-intercept? Go across the x-axis. Right, and specifically have a point at that location on the x-axis. So that one's not right. It's that one. And look, the one that you had with it is super close, and I can see the confusion. For this one, you
Oh, you
have to
haven't
do opposite
finished.
signs. So instead of
Just do
negative
all
5,
We'll come back and talk
negative
All right, guys, let's say 5 more minutes to get it wrapped up. If you're confident in your answers, go ahead and start gluing, but we will go over them all together.
Negative 2, not just regular, negative 2.
Well, you're going to glue them on the
But imagine this had a lot of. So this one is like.
Are you trying to talk about each
For vertex form.
Let's just,
Is that what you're asking? Okay. Have you remember focus on the equation first?
You got this.
I'm
Like,
gonna ask you.
what equation are you looking at for graph G?
What is this form?
Okay. So then, what form is I in? Okay. So what's the
It's not
vertex?
standard form.
Does that match the vertex for G?
Vertex. That's vertex. What two
I mean,
numbers
here's the
stand out
vertex,
to you
right?
at vertex?
I am good.
And if that's -4, then this is -2. If that's -8, then this is -4.
This has to be an opposite side.
So is that -2, -4?
-2.
It's that scaling, I think, was what
So
was good.
immediately, I know that my vertex is -2. So right there. What is this negative?
Which one's question?
Yeah, but on the graph, what does it tell you? Equals A is negative.
We'll talk about it.
Doesn't this really start on the negative? It starts on the negative. We're talking about So there's a negative up front, it's going to be concave down. So those two things we should check for the vertex, consider the value inside the parentheses, -2, -4. That matches up, and it's also negative concave down. So that we're on it, Why is it right there? Keep explaining it.
Because the one this was really awkward.
Yeah, we cause it right, exactly.
Which ones have more?
So we try, if you were to boil it out, it would just look like standard form. So every single one
guys using the graphing calculator instead of Okay, I got you. Glue it down then.
What's that for?
Do we need to change that?
Number types. These are great guesses, mathematical.
So what do you know about C?
It does the next year.
Okay,
What else?
so what do you know about its features?
The points of X.
What?
There's two parentheses.
Okay, so, well, you can does
And what I
equation
tell you,
C tell you the graph is concave down? Okay, what else do we know about the graph that goes with equation C?
This is going to have 1, 2 points.
Not 33, and be careful about that because we don't have vertex here. Factored form, no, factored form gives you the what?
Yeah, that's wrong. But
The x-intercepts.
maybe you were
Okay.
thinking since this is
So what would the
negative,
x-intercept be?
concave down.
It
So
would
I
be
agree
a
that it's
3,
going to be
but it'd be
concave
comma
down.
0. Remember, an x-intercept always
My
has a value
x-intercepts have to
0.
be where?
So we have two x-intercepts of 3, comma 0.
I'll pass it. That's correct.
Right, so you got to go methodically through that. You got to identify what form do I have, what features do I know based on that form.
Negative, and then you look at
Let's go over it. Thank you. Thank you. Thank you. Thank you. All right. So there will be a little bit of time for you to glue or fix things as we go through this. But here's how I have it set up. I have it already up here where I have the equations in alphabetical order and then the graphs that go with them. So what is the first equation in alphabetical order that goes under standard form? A? Ooh, I don't have equation A. Equation B, right? F of x equals 1/3 x squared plus pi x plus 6.4. Going with graph B. What did I say? Flip that. Equation A, B, I will get it right in a second. Equation B with graph A. That's the one we should have. Okay. So, what's the next equation? Next equation is F with graph D. And the last equation, H with graph C. Okay. These are the correct answers, but there should be a couple of questions. There's a couple of things that I will directly address. But what are your questions about those pairings before I give you information? What are your questions? Or are we good with all three of those? Yeah, that's a great question. So humble. Yes, sir.
What's the middle one say?
It's equation F with graph D. Why? No. If you messed up, maybe you scratch out the equation and write the correct equation with that graph. But are there no questions?
No.
Okay. Two quick things I want to point out is if we see standard form, what two features should we immediately look for? Well, we should look for an exponent because it's going to tell us if it's quadratic in standard form. But say it again, Cole.
Concavity.
Concavity is a feature of the parabola that we should look for. And what else? And our y-intercept. Don't forget, when I see standard form, I should look for concavity and y-intercept right away. Right? A y-intercept of 0, 6.4. Boom. A positive a, so concave up. A y-intercept of 0, -1. Positive a, so concave up. So a couple of things I do want to point out, because this should be a little bit of a struggle to wrap our minds around some of this. When I look at equations B and F, I'm going to focus on just those two. If I look at equations B and F, how could I identify what the axis of symmetry is? Anybody remember? It's the line of symmetry, yes, but how do I figure out the line of symmetry from the equation in standard form? I don't have the root, so I can't do mean, huh? Well, maybe, but I'm talking about from the equation. I don't have a graph yet. A is involved.
X equals minus B
Divided by 2A.
There we go. If I have standard form, the axis of symmetry is x equals negative b divided by 2a. That's something we should have wanted to pay attention to. So if I look at equation B, okay? If I look at equation B, at this point, pause for a second. You'll have a chance to continue gluing in a second. If I look at equation B, what would be the axis of symmetry? X equals not pi, you're close. Negative pi. Remember, it's the opposite of b. So negative pi divided by 2. So times 1/3 or 2/3. All right, put that into a calculator. What should be the axis of symmetry? X equals what? Yes, thank you. The answer to that question. We have calculators. Let's use them. What's negative pi divided by 2/3? Y'all, by the way, you know there's a pi symbol in the bottom left-hand corner of the calculator right next to one of the letters.
I'm putting an answer.
-4.7-ish. So if I go to negative 2, 4.7, does that look to be the axis of symmetry? Yeah. Okay. What do you mean? Well, but remember, I'm trying to match this equation to this graph. So I use that equation, x equals negative b divided by 2a, to check my axis of symmetry. Well, just to check, right? To have greater precision, to have more evidence that this is the correct graph. When I look at equation F, then, where would the axis of symmetry be? X equals, so negative b divided by 2a, so negative 12 divided by 2 times, you're not sure about that, remember it's understood to be 1x squared. So x equals negative 6. So here's negative 5, a little bit past negative 5. Does that look like my axis of symmetry? Yeah. Okay, so I just want you to notice that we can use that x equals negative b divided by 2a to help check our axis of symmetry. But now we're going to look at this bottom section and talk through this. So if I have standard form, how can I find that axis of symmetry? That equation. So x equals negative b divided by 2a. Okay? But I will point this out, the axis of symmetry is not something that we should see immediately. Really, if I have standard form, what are the things I should immediately see? Concavity. How do I know concavity?
And a positive value.
So if a is greater than 0 or positive, we're looking at concave up. Up like a cup. If a is less than 0 or negative, concave
Down. Like a frown.
Concave down. I've always said like a frown, but you can say to the ground if you want. All right. There's nothing else we can see in standard form? The y-intercept. What is the y-intercept in standard form? Okay, it's tied into C, but you're forgetting something. 0, comma C. Thank you, Jade, for getting involved on that. Right? 0, comma C. Now, I want to point this out. You can memorize all of these different things. That's a very algebraic way to make this. But what should we all know about every y-intercept that has ever existed? It's got a 0 for the x. And that's important because I want you to pay attention to this. So if I let x be 0, what is 0 squared?
0.
And so a times 0 would be 0. What's b times 0?
0.
And so what's 0 plus c?
C.
Okay. So when the input is 0, the output is c. You don't have to memorize 0, comma c. If you understand that a y-intercept is when x is 0, boom, there it is. Yes, Jordan?
Wait, so you said standard form so it shows you the y, right?
Standard form always shows you very quickly concavity and y-intercept. Those are the ones you can see immediately in standard form.
So this one show you the x.
Huh? How did I get the value for x?
Yeah, you remember?
So, you're talking about right here. This y-intercept?
No, I'm saying before we.
Here? Go for it. Sorry.
You know when you came over here, you helped us use like I don't remember which one it was. One of them showed us the x-intercept.
That's a different form.
Oh, okay.
Good question. That's a different form though. Okay? So when we have standard form, remember that's the ax squared plus bx plus c, that's always going to reveal the concavity and the y-intercept right away. Okay? And so we've got our axis of symmetry, that's an equation I've told you all about. What else could I find out pretty easily based on information I have up here? Someone said vertex. Remember, if I have a parabola, what does the axis of symmetry always go through? Right? Doesn't that axis of symmetry value have the same x value as the vertex? So if I'm looking at the vertex, the x value is what?
Oh, wait, I know this. Negative b divided by 2a.
Right. It's that x from the axis of symmetry, right? That negative b divided by 2a, that's the x value of the vertex. And so you may want to even make the note that these are the same. Right? That axis of symmetry has to go through the vertex. So x value of a vertex, right? It's x equals. So how would I find the y value if I know what x is? What's a more mathematical term for that? Substitute that negative b divided by 2a in. Does anyone remember how I would show that I'm substituting negative b divided by 2a into f of x? F of negative b divided by 2a. No, that's the really algebraic way, right? That's where I started getting really big in first block. That's the really algebraic way to just say, I'm substituting negative b divided by 2a in. If I have an input, I need to get the output. That's all I'm saying there. That's algebraically saying, I'm substituting that x value in. That's it. Don't make it more complicated than that. I'm substituting that x value in. You can make that note to yourself there if you want. Okay, last detail though, x-intercepts. Have we talked about x-intercepts from standard form yet? No, and we will not until maybe starting on Wednesday, definitely by Thursday. But what should we already know about every x-intercept that has ever existed? It's on the x-axis, so it has a 0 for y. When I look at this equation, which part is my y? Not the y-intercept, the y variable, the y value. Isn't f of x the same as y?
Oh.
Right? For x-intercepts, the y is equal to f of x equals 0. So the only thing I know is 0 is equal to ax squared plus bx plus c. We're going to learn how to solve that equation this unit. We're going to learn how to solve that equation this unit. You may remember some of the methods, but we'll learn about it this unit. As I said, you don't need to know x-intercepts yet, you just need to know that the y is 0, and so we're going to learn how to solve that equation later. But what are your questions off of this information at this point? Talking about here? So notice I took the x value and I substituted in for f of x. So, for example, right, Deja right here, when we had that previous equation and I got that this was the x value of the vertex, I would then do f of negative 4.7 and put that in for x. So once you use the negative b divided by 2a to get the x value, you substitute it in for x from there. We'll do some practice with that. Okay. All right. So factored form. What's the first equation alphabetically for factored form? A with graph B. Next equation. Graph or equation C with graph E. Next equation with F. What are your questions off of these three before we look at defining those features? So what are your equations before we start going over those features? Sounds like none? Evan, did you need me to go back? Okay.
Can you put it up on this one?
Huh?
Never mind.
I would say it's there, it's just smaller because I have it in presenter mode on my laptop. Okay. So equation A goes with graph B, equation C with graph E, and equation E with graph F. That's exciting stuff. I know. It's like we're learning and stuff. Mr. Kenny's crazy, but he knows some things. Just some. I've learned. Yes, Jordan.
E and F for factor. So what's the difference in? Wait, never mind.
You sure? Okay. All right. Well, let's talk about it. If you have factored form, what should you see right away? The x-intercepts and concavity. Concavity, once again, if A is greater than 0, concave up. Specifically, I will say, because of space, I'm not writing this, but what is concave up? Being clear with that language. So what's the shape, what's the name of that shape? The parabola. It's not a U. The shape of that curve is called a parabola, right? So we really should say parabola is concave up. I just don't have a ton of space. If, well, yeah, if it's concave up, yeah, it has a minimum. If A is less than 0, concave down. And again, right, really the parabola is concave down. And I believe you all also said x-intercepts. Okay, so how do I see the x-intercepts in that equation? R1 comma 0 and R2 comma 0. What do we need to be careful about when going from the equation to those x-intercepts? We need, well, it doesn't always make it negative, but it's always the opposite, right? That's one of the things that gives a lot of students trouble. We got to remember that it's always the opposite. Does anyone remember why we use R in this case? Roots, right. In the equation, they're called roots. We're going to study a little bit more about that in the next unit that we cover. But those are all called roots for those x-intercepts. So axis of symmetry, can we find that? Now I'll point out, these are the easy ones to find. Can I find the axis of symmetry, though, from that equation? Okay, how am I going to find that axis of symmetry? Say again? The mean of the x-intercepts. Remember, the axis of symmetry is always right in the middle of those x-intercepts. Or right in the middle of your roots. We'll even get to, right, so boom, right in the middle. So x equals, how am I going to average those two roots? How do we average things? Add them up. So R1 plus R2 divided by 2. The average. And so again, like you can memorize that equation. You can just be like, oh, I just need the average of the roots. That's it. You get the average of the roots. You got your x-intercept, or axis of symmetry. X just equals that. And so what would the vertex be? So the x value would be the average of the roots. How would I get the y value? F of There we go, right? So I'm just going to substitute that x value in. That's all it is, right? I'm telling you, or I'm algebraically showing that I'm going to substitute that r1 plus r2 divided by 2 in for f of x. What about the y-intercept? Can I get it? Anybody know how? Huh? Substitute what in? Not the x-axis. I can't put a whole x-axis in.
Zero.
Substitute 0 in for what? So not the x-intercepts, but in for the x values. Because remember, what do we know about every y value that has, or y-intercept that has ever existed? The value of x is 0, right? So again, x is equal to 0, and so f of 0 equals. That's it. Now we're going to see a really cool feature here. Notice I substitute 0 in for x. What is 0 minus r1? Negative r1. 0 minus r2. Anybody know what this would come out to be then? Not negative r3. What's a negative times a negative? Positive. So it would just be a times r1 times r2. So the x value would be 0 and a times r1 times r2. Now, do you want to memorize that?
No.
No? Okay, so how did I get there so that we don't have to memorize it? I substituted 0 in for x. Yeah, you can totally memorize that if you want to. That seems silly. Substitute 0 in for x. And so please note we're like defining these things algebraically. And we can define them algebraically, but is there an easier way?
Yes.
So go to the nature of them. Go back to the core of what does it mean to be a y-intercept? Ah, x is 0. So I'm going to substitute that x equals 0 in. There are some things you're going to have to memorize. You're going to have to know, well, you don't have to memorize this formula, but you need to know that the x value of the vertex is the average of the roots if we have factored form. You've got to know, right, what the roots are, how to identify the roots. But stuff like the y-intercepts, you don't have to memorize. What are your questions before we continue on to the vertex form? James like, I'm just chilling, Mr. Kenny. I got to check out my nails. You're good. Huh? You got some paper left? All right. Sounds like we have no questions. Samara, are you trying to find if you have a question? What's up?
A will be 0, 2.
Say that one more time. For A, what's your question? 0, 10, yeah. Is that what we see in the graph, that it's just 0, 10? 2, 4, 6, 8, 10, right? 2 times negative 1 times negative 5. A times R1 times R2. Is that what the y-intercept is? Yeah. Cool little trick. It's a good question. All right, last form. Vertex form. What's the first equation?
I.
H.
D.
Ooh, what's the first equation?
I.
D with graph I. Notice there is no k, so what's the k understood to be? 0. So 1 comma 0. And the a is 1, concave up. You still writing lots of details down for y-intercept? Sorry. I'll erase this up here then. Alright, so what's the next equation? G with which one?
Sorry, I got it backwards.
I see G with H. Do we need to talk about this one?
I think she was looking at
Equation G with graph H.
Oh, I don't have G.
Oh, that's right. Yeah. Anybody need me to talk about it? Okay. So finally, equation I with graph G.
I don't know my bed.
You're good. I don't know my alphabet.
I can't spell.
Alright, so just a couple, 30 seconds or so to get our equations and graphs down.